Hi, and welcome to the fifth video in lesson 1. Now that we have been looking at the overview of the general Leap user interface, we can start setting up a model in Leap. So for the easiness of everything, we are looking at how to set up a model from scratch in Leap. In this video, we will go into the settings window and we will look into how we can set up the different aspects of our analysis. This includes, most importantly, the different yield ranges. And then we will look at the current accounts scenario versus prediction years. That has a large impact on how we further on specify our model. We also look at the scope of our model choices, depending on whether we want cost, if it's a regional model or it's a national model. We will go into whether we want cost or not and how that is specified, the main macroeconomic parameters. And then we will also touch on shared folders for collaboration, while not being a part of how to set up the model, but it is very, very practical in terms of if you want to share your model with the team. So if we have a new area, we'll open Leap. It starts in the Freedonia basic model. And then if you want to set up a new area, we of course can go into the area and click new. That doesn't show up correctly, I think, but otherwise you can click the new button, which is also up here. We specify a name, whether we want to have it as a copy of an existing model or with just the default data, and it will make a very small new model for us. And after we have done that, that's quite quick, we can then go into the settings window. If that does not pop up on its own, that is the window that is up here called settings. I think I was also showing that a little further here. So up in the top of the window at any time, you have the settings up here, and that is where you can find the basic setup parameters. These you may also need to update especially if you are working on a model later on and you need to update your current year or the range of the current analysis. Let's say you made a model that starts in that's from the current year of 2020, and next year you have to update it to 2021. That happens in settings. Or if in next year you no longer will be analyzing towards 2050, but instead 2055, that's also in the settings window and similar. We will look into that now. Now we're in the settings window, and as you can see here, it has a number of different tabs. The most important tabs when you have a new model is the scope and scale, the years, maybe cost, depending on if you want that or not. And then there are these two that deal with optimization and general calculation. And then, of course, we have something with folders. These are the ones we're going to concentrate on now. Under the scope and scale, which is the same place right now, we can see that we have some general name. Now this is the Freedonia model. You can see there's a bit of an explanation to that. That is where you can write what this general model is about. The scope, quite important to set up. Here we can see we don't have demand because that's always present. You cannot avoid it, but you can tag on transformation resources. So that's transformation sectors and resources. If you tag that off, you won't see those. Land use change and land-based resources. That is very good for dealing with domestic biomass resources. So you can see what is your aggregative biomass yield of different sources and where you can use that in the model. And it's good for controlling if you're using too much biomass in your future system. Statistical difference and stock changes. That is if you need to calibrate for statistics. We will not look into this in this course because it is fairly rarely used. Cost, as implied, that is about the cost in the model, whether you want that on and off. how that looks when you are in the input side and output side. We will also look into that, but that is not until lesson 2 or 3. Energy effects, that is the pollution and CO2, having that in the model. You can see these. Non-energy effects, special branch to apply pollution and CO2 emissions of sectors not related to energy. And then complex effects, and under that the IBC, that's also health indicators and ecosystem indicators. So you can see some assumptions on, or some results on the health and biodiversity on your use of different energy sources. Then you also have the mappings. That is the important one. That also relates to GIS. We will not work with that in this course, frankly, because I have never used it and I have rarely seen it used. There are, however, videos on YouTube from the SEI that deals with this, and I shows you it. Indicators is a side calculation module, meaning you can use that to have other not energy related results, which could be practical. For instance, we have used it when we have electric cars and we want to calculate how many chargers we will need for these electric cars and how much these will cost as a function of how many electric cars are in the system. This is not strictly an energy result, so it doesn't show up under demand or transformation or anything anywhere else, but it does have a cost impact. And it's also a result we would like to get out of the model, inside the model, without having to do side calculations afterwards. So that we can do in indicators. Now then also the scale window. So the first place to look is, what kind of model do we have? Do we have a global or multinational model? Meaning, do we have to have a relationship between multiple countries? We rarely do this. Mostly what we will be working with is the national or sub-national, meaning regional. We also say regional models. It does have some slight impacts, what I can tell from on import and exports, but not much. It's more of a designation on sizing and what you can expect. Now, subnational is very good for regional modeling, where you also can input import and export to everything outside your current region, like an island region model, or treating your region as an island model. In the national, you can also input specific, like multi-regions. We will look at that later on. And then you can also look at the relationship between trading between those regions, both in terms of power lines, but also simply, you may have a region that produces quite a lot of coal, then have to deliver that coal to different regions in your national model. Then in this country, we can specify, is this an actual country in the world? And then it will tell you if IBC is available or not. IBC, which is the, as shown over in the left, is the integrated benefits calculator. If that is tagged on, it uses some statistical results from a specific year and a specific country. And I will get more into that because it has some pretty hard parameters if you can use it or not. But it is country dependent, so therefore you can apply this to a specific country. In this case, I just chose Indonesia. It does cover most countries in the world, especially in the Africa and Southeast Asia regions. So it is fully realistic that it is there if you're doing a country region for your specific country. Here we are in the years tab, and it's quite important for setting up your model. The three first, these are some of the absolute basic information for your model range. We will actually take them afterwards because I will have to show them a little more thoroughly. The results every year, that means you can actually set up a model that only shows results more rarely, which speeds up calculation. And also, if you're not really interested in every single year, you can have this as every 5 years or 10 years. If you're doing stock turnover analysis, which we will come to in lesson 2, we have to do it as year equals 1 because we will have to work with every year. I have never worked with a model that didn't have a result every year. Again, calculations are usually done in a few minutes, so it's not usually worth it to have a model that only runs every few years. The monetary year, that is which year are costs discounted from and which monetary value do you have. So usually that would be 2016 US dollars or 2018 local currency, or when was the last year you will want to look at pricing from. So the first depletion year, if you input reserves, your current reserves of a certain resource, they can start getting depleted from a certain year. So if you have your reserves from last year or 2019, you can input that, and then it will start depleting reserves from the use that are used from that specific year. So that is quite important for your resources perspective. If of course you have tagged this on in your model. But then for the first 3, again, we will go into that. So the base year is the start of your model. So that's the one that happens in current accounts. So that is start of statistics. So when do you want to statistics from? You can give statistics from every single year from beginning of time until today, but they will only start counting in the model itself from the base year. So setting the right base year is quite important. It should be said, and I will repeat this later on, that 2010 is the base year for the IBC, the Integrated Benefits Calculator. So that means if you have another base year, which is quite often, then that won't work. The first scenario, that is the first future year, quote unquote, where you start having difference in projections. What does that mean? That means in the first calculation year, this is usually the past, is in current accounts, and there is a scenario called current accounts which take care of that, and then over here that's in your future. That means that the leap forces all your data to be the same in the past between the base year and the first scenario year. So if you have your model start in 2010, for instance, and now is 2020, and then your model will go to 2050, for instance. That means that if you have a energy demand, for instance, it will always be the same no matter which, no matter which scenario you're in until the current year between 2010 and 2020, and then you could have differing versions depending on your scenarios, but only from the first scenario year until your end year. And of course, your end year, that is specified as your end year, which is the same as over here, and that's when your model stops. Now it's given as 2040 here, and I set it here as 2050. That does mean that you cannot have differentiating scenarios in years outside your first scenario year to your end year. So that's where you have your future model range, and where you have your statistics is between your base year and your first scenario year. So in summation and as a general principle, when do you want to count your statistics from? That's your base year. What is this year? That is the year before the first scenario year. So usually I would say now the first scenario year, if you were to make a model today, would be 2021, because we are in 2020 as of this video. And then when do I decide when my calculations should go towards? That could be, if you want to be in line with IEA right now, that would be 2040. We have mostly done 2050, and some scenarios already now goes towards 2060. And if you want to do emissions in line with IPCC, you might actually want to go to 2100. which is in 80 years. But that's how you define that. That also means that every data you give for the past have to be given in current accounts. Otherwise, it will start doing things between the base year and the first scenario year that might be a little wonky. We will talk a lot about that in scenarios, which is in a few videos. Now, for costs, to totally change gear. Now, do you want cost in your system? That was in scope and scale. If that has been tagged on and you do want cost, then you can say, what do you want your cost for? You can have it only on the supply side, on the demand side. And also, do you want your externality cost on? If you don't want to do that, you can also you can just have it as business analysis. We of course recommend having externality cost, so you can put cost on CO2 and put cost on other pollutants such as PM2.5, which has a real effect on your country. Then you can also set a discount rate and also set inflation rates if that's what you want. Usually we mostly work with a fixed cost, fixed year currency, which means we don't have an inflation rate, but you can decide that for yourself. Then in calculation, you can tell if you want to show calculation process. Generally, I just have that on because I quite like having that window. And then you can tell it to save if you have some instability in your computer, to save after each scenario is calculated. And also if you have a really big model, that might be a good version to have. You can also, by using optimization, of course, you can have iterative calculations. So you can say that you want a maximum number of iterations. Otherwise, you might bog down your computer for too long and too much. And while you get the more iterations, the more precise the result you get. The last iterations are usually the longest, so your benefit from having more iterations is getting smaller and smaller by each iteration. And the same thing with a convergence. You can say, when is it enough in terms of calculations? That when you decide when it's within convergence. Then in the terms, then allowed growth rate on percentage share is not recommended to put it on. The same thing, it is recommended sometimes to allow efficiencies to be greater than 100. That is good for heat pumps, where you can specify the COP as a greater than 100 efficiency, depending on how you analyze your model. But in the general way where you have input for heat pumps, something like heat pumps as the electricity and output as heat, then you would have an efficiency greater than 100. But this is a check. It will throw an error if you have this on and you have an efficiency greater than 100. Sometimes that is a good thing to have, but it can then you can check that. You can say, do not check shares that sum to do not check that share value sum to 100. I absolutely recommend you do not put this on, because it is a very regular mistake that you have shares in a given system, let's say the share of different technologies to comply with a industrial sector. If they do not sum up to 100 in every single year, the general model, if you do not put this on, will throw an error, and it's usually for good reason. So I would leave this unchecked. And then meet accelerate needs from same process as possible. That's usually good. And then the general here is just have it as standard. This is the standard, the way you have it. There is a disallowed growth rate over 10%. If you have a very high growth rate country or region, this you may have maybe you should take off, but in most cases that is unreasonable to have a very high growth rate from year to year. And this is a check for that. And then assume no regional trade. That is practical if you have a national model, but if you have a multi-regional model, you may want to put this off, because then regions can trade with each other. We may go into that later on when we talk regions. I will now talk about the folder section or the Photos tab, which is very useful for when you want to do collaboration. I will not touch on the internet and the optimization tabs. We will use an inbuilt optimization engine that is free, but you can also specify another one if you have a bigger commercial optimization engine that you do there. But in terms of folders, the areas, that's just where the model or the software saves the different areas, which is practical, but it's mostly in a standard way. If you do have something like OneDrive or Dropbox or something that can back up to a cloud, or just internally in the office, that might be practical to have the model save your changes to that place instead. In terms of shared areas, that's the other important one. Here you can specify a place where it backs it up every time you close the program, and so everybody can have the newest version of a certain model. This is useful if you have an Office NAS drive or shared hard drive, or you have a shared Dropbox folder or OneDrive folder or something similar where you can share your model.